Welcome to Are You Chemistry GCSE Ready? This playlist takes you through loads of example questions and guided solutions for every single topic in your chemistry GCSE. So it's a perfect way for you to test your chemistry knowledge. If you feel like you need a quick review or you just want the ideal revision companion for these videos, then make sure to download my free chemistry GCSE revision notes. I've linked them in the description below. Or if you're ready, let's dive straight in. Organic chemistry. So what do organic compounds all have in common? Well, they are all made of carbon and then other elements as well. That's what makes them an organic compound. And we've already seen with our hydrocarbons an example of an organic compound. They have various lengths of these carbon chains, and we can sort them into groups. So we sort them into homologous series. And within one particular series, what you will have is you'll have these different carbon chains that differ by this unit of CH2. They all share a functional group, and when we have a little look at different examples of these homologous series, we can talk about what their functional group is and what that really means. And they share the same general formula. They have very similar chemical properties, and they show a trend in their physical properties as well as you move along in length of the chain. Okay, display formula names. What makes a display formula unique? Well, it's a visual representation, which means I can actually see all of those covalent bonds. So I know which bits have a double covalent bond or a single bond and how these different elements are bonded together. How do we name organic molecules? Well, we use a prefix, and the prefix gives us some important information because it tells us how many carbons are in the chain. So each number of carbons in a chain has a particular prefix. And in your notes, you had that mnemonic to help you. My elephant plays ball for the first 4 prefixes. This kind of meth prefix at the start means 1 carbon, and so on and so forth. So you need to learn that table. Suffix tells you which homologous series or functional group your organic molecule belongs to. So if I'm asked to draw displayed formula for propene, the prop is my prefix, and that tells me that there are 3 carbons, and from my mnemonic that was the play in my elephant plays, propene 3, and the ene is because it's an alkene, and that's the homologous series that has this functional group of a double covalent bond for 2 carbon atoms here. So it contains that. So I start to build up this displayed formula picture now, and I'm going to start with the 3 carbons that I know are there, and I know because I belong to this functional group with this double covalent bond, I know that 2 of these carbons have this double covalent bond in between them. And then I think back to a piece of information that I know, which is each of these carbons have to have 4 bonds. So if I start with the one on the left, it currently has 1 bond, it's just bonded to that next carbon, so it needs another 3, and there's where my hydrogen all come in there, 1, 2, 3. And then my next one already has 3 bonds. It's got 1 on the left joining to that other carbon, and then it's got 2 where it's got that double covalent bond with the other carbon. So actually it just needs 1 more. So it bonds with 1 hydrogen. And then finally, that one on the right already has 2 from that double covalent bond. So it needs 2 more. So I stick 2 more on there. Okay, alkanes. So what makes alkanes unique? It's because they are hydrocarbons, so they are only made of carbon and hydrogen, and they only have single bonds, okay, different to my alkenes from the previous slide. So that means that they actually don't have a functional group, and really it's their lack of functional group that is how we identify them. Where do we get them from? Crude oil, petroleum. Okay, just to contrast those with our alkenes, so what makes alkenes unique is, again, they're hydrocarbons, so they're made of carbon and hydrogen, but it's their functional group that has this double covalent bond. and that makes them unsaturated as well. What is their functional group? It's that C double bond CC. Okay, and so you do have some functional groups that contain oxygen, so no longer just talking about hydrocarbons. And what is the alcohol functional group and how are they named? So, for example, alcohol is one of them. It has this OH functional group, and the name ends in anol, okay, such as ethanol, which is one that you might have heard of, quite a common one. What is the carboxylic acid functional group and how are they named? So carboxylic acid has this functional group here. So you can see a carbon, it's double bonded to an oxygen, and then some single bonds between oxygen and hydrogen as well. And the name ends with anoic acid. What is the ester functional group and how do we make esters? So there's the ester functional group, and what you have to do is you have to react one of these alcohols with a carboxylic acid, and it will also make water as well as an ester. So draw the display formula, for example, for ethanoic acid. So what I'm thinking here is that prefix means 2 carbons, my elephant, F, good, 2, and anoic is my suffix here, and that means I belong to the functional group of my my carboxylic acid functional group. And so I know I'm going to be using that functional group as well. So what I'm going to do here is I'm going to draw in my 2 carbons, and then off one of those carbons I need to include this functional group, and then I need to check the bonding. So the first C has only made 1 bond, so it needs 3 more. So these are where my hydrogens are coming in now. The second C has already made 1, 2, 3, 4 bonds, so it doesn't have any more, and it's all done.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Tips and tricks for this section. So when you're asked about the properties of organic compounds, don't forget that they're simple covalent molecules, okay? That's what they are. And everything you've learned in your covalent structure topic will apply to these as well. When you're checking to see if the displayed formula are correct, remember that the angle between the bonds and the orientations of your molecules really doesn't matter. The only thing that matters is to check that your atoms are connected the right way, so that the right things are bonded to the right things and that they have the correct number of bonds as well as a double check at the end.